All right, so 214, we are using proportions, which we've actually been doing this entire year so far, just in small little chunks. Right now, we're actually going to just have like a concrete unit on using and solving proportions to answer problems. So this problem's a bit long, but we got this. So 5 players on a television reality show are stranded on an island as a part of the competition. The group is given 50 cups of rice with a 1 cup scoop plus bottled water for nourishment. And they are dependent on their surroundings for shelter. So, since the rice is so important for their survival, they need to figure out how to divide the rations fairly. Evan suggests dividing the rice equally by giving 10 cups to each person because there's 5 of them and 50 cups of rice. Alan says this is unfair because he weighs more than the other contestants, yet his proportion of food is the same. Becca agrees with Alan, suggesting they find a more fair way to split the rice. They discuss ideas as a group and agree that everyone will get at least 1 cup. They decide that rice should be given in proportion to weight. Since they have no other measuring tools besides the scoop, they decide that only whole cups of rice will be distributed. So the 5 players and their weight are shown in the table here. We need to find a distribution of rice that is consistent with the players' agreement. So the total cups of rice is going to be distributed evenly or proportionally among the players based on their weight. So we're going to find the total number of cups and the total weight of all the contestants. So there are 50 cups of rice for a total of 880 pounds for the contestants. So I just added up Alan, Becca, Chris, David, and Evan, added all their weight, and that was 880 pounds. Okay, so then I want to set up something proportion to figure out how many cups of rice each person should get based on their weight. Okay, so for Alan, I'm going to use A cups for Alan. Alan's going to get A number of cups divided by his weight. Okay, they're equal proportions. Okay, so I can cross multiply to figure out how many cups each person would receive. So we'll find that first, and then I'll do that same thing for Becca, for Chris, for David, and for Evan. Okay. So for this first one, I'm going to cross multiply the 50 times the 297 equals 880A. Okay. So we cross multiplied, and Alan should receive 6.875 cups of rice, but since they only have full cups, let's round Alan to 17 cups. So Alan is receiving 17 cups. I'm going to do the same thing for Becca, and then I'll do the same thing for Chris, for David, and for Evan. So I cross multiplied and just rewrote it because I don't have a ton of room here, but what you see in the dark blue is exactly what I did for Alan originally. And then we do the same thing for Chris, David, and Evan. Okay. And then once I do that, I can solve, and it looks like Alan will get 17 cups, Becca will get 11 cups, Chris will get 9 cups, David will get 7, and Evan will get 6. Okay, and if I look at their weights, just to make sure that this is kind of making sense in the context of the problem, Alan weighs the most, he's getting the most amount of cups. Evan weighs the least, and he's getting the least amount of cups, and it looks pretty good. But using our results from part A, find the ratio, and they're giving us the ratio, write cups of rice per weight of player for each player, and write each as a decimal number. Is the distribution fair, and how are we judging fair? Okay, so I'm going to take, for Alan, hit the number of cups he gets 17 cups per his weight, which is 297 pounds. So he's getting 0.057. I'll do the same thing for Becca, same thing for Chris, David, and Evan. So if I'm trying to describe this in the context of the problem, well, I just did a ratio. So what do these decimals mean? This 0.057? Well, since it was a fraction, I'm actually dividing, and this gives me a percent. So if I converted this all to a percent, then yes, the distribution is fair. They are all receiving proportional amounts of rice, about 5.7% of their body weight in cups of rice. Okay, now moving on to, what's our next one? Solving proportions. Here's some, just a good reference for how we solve proportions if you're a little bit confused. Up above, here's a nice example that you can refer back to. We're going to go on to number 2. A paper company has been reducing the size of its paper towel rolls in an effort to address rising costs. To keep the price the same by providing less of the product, the company can recoup the increasing cost to manufacture paper towels without customers paying more per roll. So, before the size reduction, 138 sheets of paper towels cost $3. What is the cost per sheet? So we're trying to find cost per sheet. So cost per sheet. Well, the cost was $3 per the number of sheets, which are 138 sheets. If I divide that out, reduce, I get approximately 2 cents per sheet. Okay. If the CEO of the company still wants to charge $3 for the roll, how many sheets need to be in the roll to bring the price per sheet up to 3 cents per sheet? Okay, so we're going to set up a proportion here. We still want to charge $3. We don't know how many sheets will be in that roll, but we want to bring the cost per sheet, instead of 2 cents, we want to bring it up to 3 cents per sheet. So it's essentially the same thing that we just did, except we're working backwards now. So again, $3 for the whole entire roll. We don't know how many sheets are in the roll, thus the X. But we do know the price for one sheet is 3 cents per sheet. So I can cross multiply here and solve for X, and X would be 100 sheets. So this $3 will now get you 100 sheets instead of 138 sheets. Is this a significant difference in the number of sheets? I don't know. I mean, 138 sheets to 100 sheets. Yeah, that seems like a pretty good difference. But let's determine the percent change to quantify your answer. Just because going off of my, it looks pretty good. That's not really a good answer. So let's use percent change. Remember that formula is final minus initial over initial. If you don't remember that, Google it. Okay, so the final price was $100 or 100 sheets minus the initial 138 sheets divided by the initial 138 sheets. If I solve that, it's negative 0.275, which in the context of the problem means that there is a 28% decrease in the number of sheets. So, yeah, it's like a quarter of the sheets being taken off. I would say that's a pretty significant decrease, but what do I know about paper towels? Okay, some more examples here on solving proportions, cross multiplying, all that fun stuff. Little bit more in-depth cross multiplication here. So if you need to, I always call this the butterfly method. You make a little pretty butterfly here, cross multiply. So I get negative 3 in purple, negative 3 times x minus 1 equals 5 times x plus 1. Doesn't matter which side goes on, it's equal to each other. It doesn't matter which way I write it. You could write it the reverse, but you're going to solve, distribute the negative 3, distribute the 5, combine like terms, throw things to the other side of the equation. Eventually, you'll get x to equal negative 1/4. Okay, and then the last one here that we're going to do together, number 4, hold on. For any proportional situation, there are multiple ways to make comparisons and set up the equation. So you're not just reduced to like this is the only way you can set it up. You can have it pretty much written any way, as long as the comparisons made in each ratio are consistent, the proportions will be correct. So Ben and his roommates order pizza and Chinese takeout for dinner. Ben tips the driver $5 for a $21 pizza. How much should he tip the driver who delivers the Chinese food if the Chinese food costs $34? So that he tips each driver the same percent. Round your answer to the nearest dollar. So then set up 4 different proportions to solve the problem. Okay, so let's just dive right in. First one. Okay, we know for hard fact, Ben is tipping $5 for the $21 in food. So if I wanted to set it up the same for the Chinese food, I could have X tip, I don't know how much the tip will be, for the $31 in food. And then I can cross multiply. Okay? I could say $21 worth of food will give me a $5 tip. I just flipped the fraction upside down. If I did that, I would have to do the same thing for the other side. I'd also have to flip, and that's a typo. That should actually say $34 worth of food, not $3. If you solved that, you'd get something totally different. Okay, so notice, same deal here. I just flipped the fractions. Food on top, tips on bottom, tips on top, food on bottom. Okay, or I could also set it up comparing tips in one fraction and the food in the other. So $5 tip versus some other tip. The $5 tip goes with the $21 in food. The X tip goes with the $35 worth of food. I could solve it that way. I could also, like I did before, I could just flip these 2 fractions and solve. No matter which way any one of these, so long as you fix the typo on number 2, you'll get an $8 tip. If I solved all of these, cross multiplied, solved for X. All right, and then that's it.